Today we want to talk about buttons. Now in your toolkit, hopefully you have it there, you can look in it, you should be able to see that you have one of these little things. This is a button switch. See if I can get a better view of it for you. The way this works is it has four legs, but these legs are the same pin and these legs are the same pin. When you press the button, you make a connection, just like an ordinary switch that you might have seen in electronics, from one side to the other. So that just makes a conducting path, no conducting path when you're not pressing. You can take your board and plug it into your board, but it doesn't always go in very well. This, as a matter of fact, is kind of a bit of a nuisance. And the way it is, you also need some resistors to wire this up properly to correctly use it as a digital input for your board. So we've also given you one of these. There's a diagram in your book that explains the choice of the resistors that we have here. So there's two little resistors, right? See if we can get the focus on that. There we go. Two little resistors on this little piece of circuit board. And on this side, we've got two sets of pins. These go into power and ground. They're just there to make a nice snug fit. And this is the signal pin. You take this button, see if I can see this easily, and you just snap it into place. Okay? So the pairs of pins hold it into the power and ground quite strongly. And then you take a wire and connect it into the signal pin, right? And then you take the other end of the wire up to where you want, to whichever pin you want to be the digital input. And then when you've configured it correctly, then button's on, button off. Just a couple of points here. A digital input is simply like a really simple-minded voltmeter. It can only read if a signal is 0 volts, low or off, or high, 3.3 volts. So it can read that it's 0 now. If you press this down, it'll read that it's 3.3, high, in other words. So here's a figure from chapter 8 of the course notebook. Shows you what this little button circuit is like. Here's our little button, and its purpose is to make a contact, a conducting path. This end is the power line. This end is the ground. Okay? And there's two resistors here. A small one of about 200 ohms. And a larger one of 10,000 ohms, 10 kilo ohms. Now the purpose of this is that when the button is opened, the pin is connected to ground, so it's definitely at 0 volts. When I press this button, I've connected the power in. Now the power can go two ways, down to ground or into the pin. Into the pin is the signal that we're sensing. The input tends to be a large resistance. So since this is a small resistance, the voltage going in is pretty close to this 3.3 volts. And so it'll read high. If I didn't have any connections here, we would say this pin was floating. And any sort of external noise could send it high or low. It would be reading randomly. Even your body's electric field could change what it read. This ties it to ground when it's not in use, and definitely gives you a high voltage when you want it. Here's a short little program that I've used to demonstrate the digital input using a button. Okay. I'm going to use PuTTY to show the effects of the button. So I've got stdio, configure usert, and putty.h here. They'll let me print to PuTTY. I also have configuration bits. Anytime I want to use any of the pins, I need to have this in here. And of course, xc.h is standard for using any of the functions that refer to the chip. Okay, so come down here, configure the usert, clear the screen, wait for enter. So we've seen all that before. We're not interested in that. This is the line that's important to us. Here, I've configured RC3 as an input. Remember, when it was 0, it was an output, and I use that with LEDs. This is how I configure it as an input. Set it to 1. So I'm using pin RC3. That's pin 14. It will read a button, and the only values it will read are 0 or 1. Okay, in the while loop, we'll see how that works. When we had an LED, this would controlled whether the pin was on or off. Okay, we could set it. Here we can't change this value. This value is set by you pressing the button. So if you press the button, then it will in fact be 1, and so this will be true. And if the button is up, then this variable will be 0. So we're reading this variable. Before it used to be a control, now it's an input statement. So let's look at PuTTY. Okay, look at PuTTY, pull PuTTY up here, and I'm going to load this program, pull it back up, restart the session, okay, and it should be waiting for enter. Oh yeah, look at that, it's going wild. I'm not pressing on the button, so it's reading button and pressed. It's printing up many times a second because this is a fairly fast computer chip. I'm going to press the button now. Press off, on, off, on. Wow, isn't that impressive what I've just done? Okay. Now, most of the time, when you use a switch, you might think of something like a light switch. You flip the switch and the light's on. You don't have to keep your finger on the light switch to keep the lights on. That sort of behavior is called toggling. And just to show you what we mean, here's of the button signal. It's digital. The button is either on or off. What we want to happen is when we press the button, we want the behavior to continue, say a light being on, until the next time we press a button. And then the next time after that, it comes back on and off and so on. This rise is called a rising edge. It's where the signal goes from low to high. This side is called a falling edge, where the signal goes from high to low. So what we need is some code that looks at the signal and finds the changes in the button status, not what the button status currently is. So here's a little program that shows how to use that toggling. What I've done is I've created a little header file excuse me, called buttons.h. You'll find that in the sample code on the Moodle site. And let's have a look at that. All it does is it has this last switch 1 value. And what it does, it monitors the input pin, and it assumes it starts off low. If the last number was low and now it's high, then yes, you found a rising edge. But if the last switch value was 1 and the digital pin is low, then you've got a falling edge and it reports back at 2. Okay? So 0, nothing's happened. If it returns a 1, then you've got a rising edge. If it returns a 2, you have a falling edge. Now you might only be interested in rising edges or just falling edges. Depends on what you're trying to do. So let's minimize this one and go back to the main. So what I've done, I've got a variable has switch one changed. And inside the while loop, we've got this function always monitoring RC3. Okay? So it's reporting back 0, 1, or 2. 0 if there's no change, 1 on a button press, 2 on a button release. And just to see what's going on, I've created two little functions here, right? Switch one rising edge action, switch one falling edge action. And they're very simple functions. Button pressed, button released. So let's load that onto the chip. Okay, and call up PuTTY. Hit enter. Okay, nothing's going on because I haven't pressed any button. Here I'm pressing and holding the button. Holding, release. Ah, it's released. Right? Press again, release. Press, wait, release. Press. Do it really quickly. It's slower. And that can be used in all sorts of programs. And of course, I'm going to get you to use it in all sorts of programs. So that's it for now. Thank you.